Yeah. Hi guys, my name is Jayant and you can also call me correct since that's the most cheekiest name I could think of. Anyways, in this video, I'm going to show you how to build your own custom gesture control mouse, and at the end, you should be able to do something like this. You should be able to move your mouse around, well, not your mouse, but move your cursor around using just your hands. You should also be able to, perform left click, right click, and hold and drag operations. So I'll be coding in Python and these are the libraries we will be using. I'm assuming you have a little bit idea on what OpenCV is and how to use it, how to take input from a webcam and how to display it as output. And regarding mediapipe, if you know about it, that's great. But even if you don't know what mediapipe is or what it is being used for, that is completely fine. So yeah, and if you are here just for the sake of code and have no interest in watching tutorial, you can simply skip it and go to my GitHub and clone the repository from there and use the code as you like it. All the installation instructions as well as the usage guidelines given in the readme file. Anyways, let me give you a brief intro on what mediapipe is. So mediapipe is basically an open source framework developed by Google which lets you do a lots of machine learning tasks. And using mediapipe, you can do lots of things such as object detection, image classification, hand gesture recognition, hand landmark detection, face detection, face landmark detection, and all that. Apart from this, visual task, you can also do text processing using mediapipe. You can do text classification, you can do text embedding and language detection. And in addition to text processing, you can also do audio processing. You can do audio classification and audio embedding as well. Well, I think this is coming soon, so in near future. So anyways, these are all the things you can do using mediapipe. And one thing I would like to mention is mediapipe is being known for being very lightweight, and since it is lightweight, it is mostly used in mobile devices and edge applications. So yeah, the only module we will be needing for our project is this one, hand landmark detection. Now you may ask that why we are not using hand gesture recognition and why we are using this. Well, because it has obviously a word of our project in it. The reason for that is this particular module, hand gesture recognition, might not have the gesture we need. Like it have a fixed number of predefined gestures. So it may have thumbs up, thumbs down, pointing up, and pointing down, and all that. But we want to make something custom, right? And it might not be necessary that custom gesture would be included here or not. So for that sake, like since we want to do it from the scratch, we will be opting for this hand landmark. So if you see the demo, you should be redirected to a site which should ask for your camera permission, and once you allow it, the inference would run directly into the browser. And you could see the inference is on, and if I put my hand up here, you should be able to see like it is detecting quite nicely. If I put my other hand, it also detects this. So there are a number of parameters here, demo num hands and minimum hand detection confidence and all that. You can play around with it. If I set to demo num hands as 1, which was initially set to 2, the inference should run again, and again it is detecting my hand quite properly. But as soon as I put my other hand up here, it is not detecting it unless I remove my previous hand. Now it is detecting. If I put it, it's not. So you get the idea of it. It is detecting only one hand at a time, right? So then there are other parameters, you can play around with it, and if you are more interested, I suggest you read the documentation. And yeah, that's mostly about it. And this is the inference we'll be using for setting up this gesture control mouse. So how to get it running locally on your machine? Well, the first thing you will be needing is an environment which can run mediapipe inference. To do that, to get that environment, you simply can go to my GitHub and go to this requirement.txt, and you will find the libraries that we'll be using. You can install it manually one by one, or you can simply download it. And let's save it to a new folder. Let's create a new folder called mouse, and let's save it there. Okay, here we got our requirements file, and open up the IDE you use. I prefer VS Code, and open up the folder you just had created. So desktop and mouse. Open it, and you should be able to see like the requirements.txt there. Now what you want to do is you want to create a virtual environment with these libraries. So you can simply create a conda environment and install these libraries in that environment. Okay, just a second. Yeah, so I have already created an environment which is named as gesture mouse, and I have other one as mouse. If you are not familiar with creating an environment, you can simply do open up the terminal and simply can do conda create and name like whatever the name you want to give. Let's just call it mouse gesture. Okay, that's fine. Mouse gesture Python 3.10, and they should create that environment conda environment with Python interpreter as 3.10 version. Proceed. Yeah, so once it is created, you should simply be doing this activation conda activate. Okay, and once it is activated, you should simply do pip install read from requirements.txt, and this should install all the files, like all the libraries we require for the project. And once that is done, just select the interpreter. So I have already done it, and my interpreter, like my environment is something different. It is gesture mouse, so I will be selecting that. Here it is. Okay, so you have got your environment sorted. Now you want to proceed with the inference, right? Simply create a file called inference.py, and here we'll be writing the code for running the mediapipe inference. To get the code, simply search for mediapipe hand detection, and they should give you this result. The first site, open it, and if you see it, this Python code examples, click on the guide, and if you see it, here are the steps given, like step-by-step guide to how to get it working locally on your machine. Well, I find this guide little hard to follow, since for a live stream like what we'll be doing, like taking input from a webcam, you have to create a separate callback function called print result. May not be print result only, it may be of some other name, but you have to create some callback function, and you have to extract the result from this callback function. So it is quite hard to follow, I would say, compared to other approaches that are available. So you can follow this if you want, but there is a better alternative. You can simply go to this second site, which is called read the docs mediapipe hands. Open it, and if you scroll down, you should be able to find this piece of code starting from import cv2 and ends at cap.release. So simply grab this piece of code and copy it into your inference.py. Once you got the code, save it, and if you look at the code, see this part from line 7. It is for the static images, line 7, and we have no use of images, so you can simply remove this piece of code. So let's just remove it, and what you are left with right now is a code which takes the input from a webcam and runs the inference on it and draws the detection result on it. So if I run the code, yeah, so you should see the frame popping up, and it works just as fine as it was working in the web browser. So yeah, so what this code is basically doing is, initially it is initializing a video capture object which takes the input from your webcam, that is video capture 0, and that video capture object, then until it is open, is being read, and we save that frame into this variable called image. And once we got our frame, that frame is passed into this hands.process function for inference. And what are the result you get by running the inference? Those results are stored in this variable called results. And if a result is not none, that is something is detected, then you are looping over it, and whatever the whatever you are iterating over, like hand landmarks, that are drawn using this draw landmarks function on the image. And once you have drawn on the image, you are simply showing the image as output. So here's the thing, like what are we iterating for, right? So what does this result dot multi hand landmark contains? So how many of to identify like how many of these hand landmarks are there, you can simply do this: print length of results dot multi-hand landmark. And okay, I think indentation is missed. Yeah, it's good, I guess. So it should give you how many of these hand landmarks are there. And once I click run, you should be able to see it. Okay, so again it is on. If I put my hand up here, so the what we have just written is printing 1. If I put my other hand, it is printing 2. So 1, 2. So each of hand landmark, like the one hand landmark is representing this hand, other hand landmark is representing this hand. So there are 2 hand landmarks, and number of hand landmarks represent the number of hands in a frame, which can be maximum of 2. And here's the thing, like when you are building a gesture control mouse, it is ideal to have only one mouse controlling your whole cursor. You don't want 2 mouse, you don't want 2 devices, right? So you don't want 2 hands to control your mouse. So it would be a sensible thing to do is limit your number of hands. So you should do max num hands equals to 1, and this should limit your number of hands. And once you've done that, and if you run the code again, you should be able to see that it is detecting 1 hand, and even if I put my other hand in it, it is only detecting 1. So at a time your cursor would be controlled by only 1 mouse. So yeah, that's about the what result.multi-hand landmark consists. But what about this hand landmark part, like how it is being drawn, like what it does have? So to get that, we can simply print whatever this hand landmark is, and once you've done that, you should be able to see what does hand landmark represent. Okay, so as you can see, it is printing something like landmark XYZ, and it is quite overwhelming, to be honest. And to simplify it, you can simply print it where is it? Yeah, hand landmarks dot landmark, and this should print little simpler result, I would say. Okay, now it is printing XYZ. Okay, now look at the result carefully. It is ending with this square bracket. So what does this represent? If you scroll up, it started from here, right? So this XYZ of whatever the number of this XYZ are, this whole thing is a list containing pairs of X, Y, and Z. So we can infer that X, Y, and Z are coordinates, and how many of these pair of coordinates are here in the particular list. To do that, we can simply print this, like print hand landmarks dot landmark. So instead of printing only this, we will simply print the whole length of it, and it should give you how many pairs of XYZ are there for one hand landmark. Yeah, so it is printing 21. So you have 21 XYZ coordinates. And what this 21 number is representing to? Well, to say that, just go to your mediapipe hand detection search result and click on the images, and here you will find this particular image. Once it is loaded, just save it to the folder you had created called mouse, open it, and you should be able to see all the 21 points. So these are the 21 points your XYZ are representing to. So point 0 has a pair of XYZ corresponding to this. Then there is another XYZ corresponding to this. So all these points have a particular XYZ. So how do I get XYZ of this point, like at the tip of my index? How do I get XYZ of that? So to do that, you can simply do this. All you have to do is index it and print it. So hand landmarks dot landmark, and to index it, you should just write 8. It would give you XYZ of tip of your index. And once you've done that, just print it, and it should give you something like this. So it is printing only XYZ, not a list. And yeah, So you get the idea like how we have extracted coordinates of a particular point, but you look at it, it is in weird form, like it is in point form, it is floating, it is in like 0 to 1, that it is contained between 0 to 1 for x and y, and z is negative. To talk about x and y, like before talking about x and y, I would like to talk about z. So what this z represents to? So z basically is a relative position in 3D coordinates. So let's just say this is the origin from the camera. This is the origin, and okay, if with respect to this point is on the same plane. But if I move my hand forward, then it is closer to camera than this point is, so it is closer than origin. So let's take a look at it. Like let's take a look at my how the z varies. So I'm only printing z here. So to do that, let's just hand landmarks dot landmark 8 dot z. So it should print only z. Now take a look at my index point. So it is on a same plane approximately. If I move it forward, it is in minus, like it is closer, so it is increasing. But if I move it further back, it is going it is increasing in positive, so closer, farther. So it is compared to relative of this point, the 0 point. So it is compared to what are the point of z will be compared to relative position of your wrist. And this is a 3D coordinate, and you can use it to make this project even better, or you can think of some idea which uses z point to make other projects. But for our case, we won't be using this. Only thing we need is x and y. So let's just extract x as x equals to this thing, and y equals to this thing. So I am extracting x and y coordinates of my tip of my index. Okay, I'm not printing anything, so it won't give you any results, but yeah, let's just print it. And x and y are, I feel there's no need to explain what those x and y stands for. X is for horizontal axis, y is for vertical axis. And take a look at y here. If I move my hand up to extreme up, y is nearing 0, it is 0.07. And if I move my hand down, it is increasing 0.5, 0.6, 0.7, 0.8, 0.9, and eventually maximum it would have 1.0000. So y is increasing from 0.0 to 1 all the way to 1.0. And if you take a look at this, x is at 0.9, and if I move it to right, it is increasing it is decreasing. So you might think why it is decreasing for, because the whole image is flipped. So we should flip image only before passing it for inference. Image equals to this thing, and we should just display image as is it, and it should give you proper x coordinates. Now take a look at this. So y is minimum here and maximum here, like 0.8, 0.9. So it increases, y increases in this direction, top to bottom. And take a look at x now. X, it has minimum like 0.0 something. I move it to right and it increases all the way to 0.9, and maximum it would go is 1.0. Now you might be thinking why it is squashed between 0 to 1. Well, because x and y are normalized. And one thing about y is, I want to point that if you don't know how screen coordinates one, it is different than Cartesian coordinates. So x and y in Cartesian, x increases left to right, y increases down to bottom, sorry, down to top, right? And in screen coordinates, x increases from left to right as it increases normally, but y here increases from top to bottom. It does not increase from bottom to top, but increases from top to bottom. So your origin is at top left of your screen, not at bottom left, but at top left. So that's how x and y work in screen coordinates. So yeah, coming back to the x and y, why it is ranging between 0 to 1? Because this x and y are normalized. By normalized I mean x is divided by the maximum length, maximum value it can have, and y is divided by the maximum value it can have. So maximum value y can have is the height of your image, and maximum value x can have is the width of your image. So to get a denormalized x and y, you would simply have to multiply your x with the maximum width and your y with the height of your image. To do that, you can simply extract the image height and width as image height comma image width, and the third variable would be here equals to image dot shape. This should extract image height and width, and whatever the image height and width you are getting, you should just multiply it here with x multiply image width, and with y multiply image height, and this should give you an original value of x and y, not normalized value. So you see it is like 480, 140, something like that. If I move my hand up here, we should get minimum value. So it is currently ranging for 20. If I move it again, so it should ideally start at 0. So y ranges from 0 to all the way to 100, 200, 300, 400, and maximum it is going nearing 450, 460, something like that. And take a look at x, and x is ranging from 10, like it would be starting from 0 to all the way to 300, 400, 500, 600, and somewhere around 630. So maximum value y will have is 480, and maximum value x will have is 640. This is for my camera, like my webcam. My webcam outputs, it is 480p. So maximum y it will have is 480. If you have better resolution, the y will range more, and x will also range more. So it depends on the camera resolution. Mine is 480p, so y is ranging from 0 to 480, and x is ranging from 0 to 640. So yeah, you got the idea of how do we extract x and y for a particular point. And we can similarly extract for all the points, like for all the 20 coordinates. We can simply have something like this for each frame. We can maintain and list of x and y, which should be empty, and if there is a result, instead of printing it here, just x dot append whatever the result is, and similarly y dot append whatever this is. But to get all of this, we would have to loop it. So let's just for I in range 0 to length of hand landmarks dot landmark, that is this with the ideal range from 0 to 21. X dot append, instead of 8 I should write here I, and instead of 8 here I should write I there too. Let's fix the intent. X dot append, and we are appending x, we are appending y, and once you append x and y, just do this x comma y. Okay, there's an error here, I guess. Yeah, it's capital Y. So you are appending for all the 21 coordinates, and let's just see if it works. So yes, it does. It is printing a list of values, which is x and y of all the 21 coordinates. So what we have gone through this video, like what we are seeing throughout this video, is that how to run an inference and how to extract points of each coordinates, how to get x and y of each coordinates. Now the only thing we will be looking for, going forward, is how to utilize these coordinates to move your mouse. Like we know how to get coordinates, and only if there was a way to move mouse using coordinates. Well, there is a library called Py-GUI, lucky for us, and we'll be seeing how to use it. See you in the next video.